that when x is within this interval, y is within the chosen tolerance of positive 2. I'll let you guys get that. So we're trying to prove that the limit of this linear function is 2. In order to do so, we wish to find for any tolerance epsilon around positive 2 an interval of x values around negative 2, so that when x is within the interval that I find, it turns out that all the y values stay within my little tolerance around the special y value of positive 2. So then to try to support that, you always can start off with your function minus what you think the limit is. Our function in this case is 1/2 x plus 3. I think the limit is 2. And so I clean that up a little bit. Now here the factoring's a little trickier than it was in the last one, but remember my hint, to finish off the problem, no matter what kind of function you have, you always want to get the factor x minus a out of what you have there, okay? So we're purposely trying to factor out x minus negative 2. So I'm going to factor the half out, and that gives me x, okay, 1/2 times x is that. But then what would have to be here so that a half times this number equals 1? 2. Okay, and that is equal to x minus negative 2. Distance of x values from negative 2. So instead of using the delta this time, I just went ahead and wrote down the absolute value of x minus negative 2. Let that be less than epsilon divided by half. Then the function minus 2, we already showed equals a half. And it will be less than a half times epsilon over half. So for any epsilon chosen around y equals 2, choose x values within epsilon divided by half. If you want to rewrite that as 2 times epsilon, that's perfectly fine. Of -2, and the corresponding y values will stay within epsilon of 2.